Welcome to a new episode of the Data Discovery channel. And today my guests are Lucia and Zina, colleagues from InfoSupport. And we are going to talk about anonymizing video. And now you might think, why would you anonymize video? But maybe, it's best if I ask you, why would you want that?
So the thing is that this project started actually as an assignment for one of InfoSupport's clients, the PassPop Festival.
Yeah.
And they have a very specific case where they really need to anonymize their data because they have video recordings from their surveillance system, both inside the festival and on the outskirts. And they would like to be able to store this video so that in the long term they can analyze it to find patterns in traffic. So for instance, in both the cars or the people who are entering the festival. Yeah. In that way they could adjust their logistics or their security bodies, etc.
Yeah, and normally they are not allowed to store that video.
Exactly. Before the GDPR, I think it was possible up to a certain time. Yeah. But right now they are not allowed to do so, especially for the long term, unless they can guarantee that the video is completely anonymized. And in that case, GDPR doesn't apply, so they are free to store the video.
So that was the problem. They were not allowed to store the videos, but they wanted to do analysis of the videos, for example, a year later for the next episode of the festival.
Exactly.
And the solution would be, remove all the facial or recognizable items, and then it's okay.
That was another problem because I have a slide here. We know that we want to anonymize video, but what does anonymization mean? Because we kind of know what personal data is, but within the GDPR they have a very specific definition, which is still, it's clear what they mean by personal data, but it's still really open. So what they basically say is that anything that could potentially help identify a person, either directly or in combination with other characteristics, that's considered personal data.
So that would also mean if you knew that I was at PassPop and you knew that I was the only person with a wooden leg or I don't know what, then it would already be...
exactly.
Okay.
So that's the thing, like maybe some aspects that seem like, okay, they are super generic. If still within the context or the image captured, it could be something specific, then that's personal data. Okay. So that's what made it was the most tricky part. And also because most personal data characteristics that we can think of, they are all visual, so we can find most of them in videos and images. I wrote some examples here which are currently considered personal data within the frame of the GDPR. Mm-hmm. And so some of them, as you said, faces are
the
typical one. But also other biometrics. So biometric data is considered like the most sensitive one. So there are things such as the posture of a person or the way that they walk. That's also considered personal data now.
Some people have a typical way of walking. You can recognize
exactly.
them.
And there have been several systems already developed to identify. So for person identification, just using the gait, so the way that people walk. Yeah. So then that means that if people can be identified with it, then that's considered personal data for sure. So.
And you have to keep that in mind when you try to find a solution for that.
Exactly. Yeah.
So, what did you do to...
So the thing is that, so of course that was the next one, like can we really fully anonymize a video or an image, and how could we do that? And so the first thing was to search for methods that already exist, right? The problem with that is, there are many different methods, but each of them has a certain issue that prevents us from fully anonymizing images or videos. One of them is mainly that anonymization techniques only focused on one specific identifier, so mainly faces is the most common one. So that means that even if it works well for faces, we still have a lot of personal data to anonymize.
Yeah.
Then other methods try to So they use these kind of filters, like the ones for faces, but to encrypt areas of the image, so that maybe an image is completely occluded, but then the original image can still be accessed.
Mm-hmm.
But that's also like another part of the GDPR where they state that if the anonymization process is reversible, then GDPR still applies. So wouldn't help for the passport case.
Yeah.
Then even if we extend these filters to, let's say, like the whole image, the whole person figure, it has also been proven that we as humans can still recognize people even through these filters. So if recognition is still possible, then it's not helpful for us.
Yeah.
And then another approach is to remove all the objects that can contain personal data. But in our case, the objects that we want to be able to track somehow are precisely the objects that contain the personal data, so all the people and all the vehicles. So then this would be counterproductive for our case.
Yeah.
And then two of the main characteristics of all of these methods that I noticed was, on one hand, that they, as we saw, they only focus on one identifier,
Mm-hmm.
which even if it works perfectly for that, there are still a lot of personal identifiers left without the anonymization. And then the other problem is that even if we manage to somehow process all the identifiers in a video, we still need to make sure that the detection of those identifiers is perfect, because even if it fails in a single frame within a video, then in that frame a person could be exposed, and then anonymization is compromised.
Yeah.
And an example was that the researchers at Google said that they are, at the time of the publication, they were only able to automatically detect and blur 89% of the faces in Street View, which means that
2% isn't so.
Yeah, exactly. So even if they have this problem, then there was something off with this kind of approach.
Yeah.
And so what we thought was, instead of doing this, so instead of trying to manipulate somehow the original video with the risk that implies, why not create a new video? Like an alternative video feed, where we only transfer the information that we want to keep without transferring personal data, ideally.
Yeah.
And that way, we can guarantee anonymity, but the issue would be that maybe in this transfer process, we are losing information that might have been useful for us.
Yeah, interesting. The last episode of the Data Discovery channel was about deepfake videos.
Yeah.
And I see some similarities.
Yeah. Yeah. And so this was basically the idea. In the first moment. And then we thought, okay, how can we create this alternative video? And then the approach was to try to infer somehow the 3D information from the 2D video, so that we could locate all the relevant objects, so in our case, people and vehicles, within the 3D space. And then that way we know exactly like the movement patterns of all these objects, but that's the only thing we keep, like the exact position on the scene.
Because that's the only thing that Passport wanted to analyze afterwards.
Exactly.
Streams of people, streams of cars, etc.
So only motion patterns and maybe just directionality, but nothing else really. So for this specific case, that seemed like the safest choice. Like, we really don't need to worry about anonymity or GDPR or anything.
Yeah.
We need to worry about potentially a big loss of information, but the risks, I guess, are not as relevant as maybe big fines from the EU. So
yeah. And did you succeed?
Good question. So partially, yes. We could see that the approach was promising, but we had certain issues, especially with the, let's say, like the hardest part of the problem, which is trying to infer 3D from 2D. So with the depth estimation, because In that case, we always know that the solution is never going to be completely reliable. And also because we ran, well, all the AI techniques that I'll explain later on each of the frames. So that meant that maybe errors in each of the frames would mean like a lot of changes from frame to frame. So yeah, the results were a bit unstable, but it could still point out like which objects, which type of objects as well were in the scene and more or less where they were moving.
Mm-hmm.
But yeah, not fully representing the 3D space as we, as humans would perceive it in the 2D video.
Yeah.
So that was the main issue, yeah.
Okay. And then you
Yeah.
took over?
Yeah, exactly. So I tried to continue where Lucia left off and specifically improve the depth estimation, which is really hard because it's a monocular image, so it's a single image. And usually when you estimate depth, you need two images because you're looking at a disparity.
Stereo view.
Exactly.
Yeah.
You need a stereo view. So that's a big challenge. And I decided that I could try to use generative adversarial nets for that, which is a type of neural network. It's actually two neural networks that are trained simultaneously, where they both try to improve each other. So that's my first approach. And the second part of it is to get more data, because right now the data sets are very limited. And you see that a lot of research starts to focus around the same data sets rather than having research that's driven by theoretical foundation. You get research that's driven by data sets that are available.
What data sets are we talking about? The video streams or other data sets?
Well, other data sets. So one of the big problems of gathering more data is that data is very expensive because it needs to be annotated. So what I decided to do is a relatively new approach in which you take data from video games. So games that are very realistic. The one I decided to use is Grand Theft Auto 5. Yeah. So the advantage of that is that games have data that's already annotated that you can extract from them. So it's cheap. You can simulate different conditions. So you can have different weather conditions. You can say, oh, do I want day images or night images? So I thought if I can use this to pre-train my network, then maybe the network will also perform better on the real-world data.
And you say these images are annotated, but does that mean that you're not only using the video that we see as a game player, but also the data from the game? Okay.
Yeah, exactly. So there's a depth image already in there. There's some stencil, there's segmentation in there. So for all these image processing problems, then I think it's very promising to get this kind of data from game companies.
And how do you access that, or are you asking the game company?
No, that's exactly the problem, is that game companies don't like it so much when you try to reverse engineer the games. So right now I've been using a mold that someone developed pure out of curiosity, but I think there's definitely some promise there, and maybe if AI researchers work together maybe a little bit with game companies, because the data is already in the game. It's just a matter of being able to extract it in a good way.
Cool, I like the idea.
And it actually did improve my model. So I got a data set of indoor images. That's it's a benchmark data set that a lot of people use for depth estimation, which consists of RGB images and depth map pairs. And when I trained my model on only that data set, I got a worse accuracy than when I first trained on the data from GTA and then on that data set. So it does actually improve the performance.
Oh, nice.
So that's really nice.
Yeah,
and I have some examples here. So you can see the original image, the generated image, and the ground truth depth map. And then the top left one is only on the indoor data set. The bottom left one is on the indoor data set that was pre-trained on the GTA data. And the top right one is from the GTA data only. And what you can actually see is that the one that's trained on GTA has less sharp edges, so the resolution is lower, but it's still better, so the network still generalizes better than when it just overfits on this specific data set.
Yeah. One of the things I remember, we did a lot with computer vision at PassPop, and one of the difficult things is lighting.
Yeah.
Because it's constantly changing, or it's low, or well, you have a lot of issues with lights over there.
Yeah.
In what way affected that, the way that you're dealing with this technique?
In this particular data set, not so much, because the images are indoor. I still want to extend it to outdoor images as well, because of course that's also more representative for the GTA data set, but as well for the PassPop case. And I think that will be a challenge. And it's also one of the things I'm looking at right now, because I also want to include biological cues. So I want to look at how humans perceive depth and implement that into my data.
Whoa.
And one of those things is indeed brightness and contrast. And we also see that humans are very dependent on things that are related to the horizon. So things that are further away have less texture, for example, than things that are closer, and they also appear smaller. You know, all these cues that I really would like to implement into my model, but that's still something I'm working on.
Yeah.
So that's quite a challenge. And then, of course, what Alicia also mentioned, I want to look at the temporal information, because every frame is related to each other. So it would be a shame not to use that correlation. So right now I'm looking into building some recurrency into my generative network, and then see if it can estimate depth over time.
Yeah, wow.
So
how much longer do you have because you are in the middle of your graduation study, yeah?
Yes,
And
so
how much time do you have left?
2.5 months.
2.5 months, okay.
Yeah, it's going to be a challenge.
I'm very curious what the end result is. If people want to know more about what you did, can they find more information? I suppose your paper is published somewhere?
Yeah, I think it should already be in the university repository if they are updating it on time. And otherwise, I think there's also a website where we, at university, we had to create some kind of like dissemination format for our thesis, like a video or a post or something. And I made a website, and it's hosted by InfoSupport, so it can be accessed, and it has basically a summary of the main points and images and videos of the main results. So that's,
well, we will include the link in the video, then people can have a look at that if they are interested. Okay. Yeah. And your material, is that already available? Or?
No, you'll have to wait until the end of April, then it's done. And then I will upload my thesis to a university repository, and we'll see. Maybe I can present something at the InfoSupport too.
Maybe you should come back to the channel and show us the end results.
Yeah.
Okay, nice. You're invited in this way.
Okay.
Thank you very much for explaining this, Lucia and Zina. Good luck with your the rest of your 2.5 months.
Thank you.
And thank you for watching. I hope you like this. It might seem complicated, but it's really thrilling to see what you can do to anonymize video. If you have any questions, leave them in the comments of the video. Then maybe we can ask these ladies to answer them. If you like the video, click the thumb icon to like it, and you will be notified about new episodes. And of course, subscribe to the channel, and you will never miss a new episode. Thank you for watching, and see you again next time.